So thank you very much for joining us today. Emmanuel Flouvat is here with us today from France. Emmanuel consults for us on all things filament winding. He's one of the two masterminds behind our filament winding machine that we have within the Centre for Future Materials. And he is assisting us with some new and novel manufacturing techniques and new materials for filament winding processes as well. So please welcome Emmanuel.
Thank you, Tristan, to give me this opportunity to present my knowledge, my experience in filament winding. So today we will speak about robotics and what I did in the past and maybe what I will do in the future. So to introduce myself, I'm born in Normandy in 1968. I was studies in the electricity, also automation and mechanics and robotics. And I was a small child. I like to play with Lego. So maybe this gives some idea to me for my future technical experience. I was also a French member of the national whitewater team of kayak in France. So maybe I start my knowledge for composite because I was working also to shape some kinds of shape for canoes and so blades and kayak shaft on some case. And also I studied in a company. I was also a maintenance technician and I was also a team leader from 1989 to 2004, but unfortunately this company closed 2004. And with Arnaud Ménard, one of my colleagues, we decided to create at this time MF Tech. This company, we start to make some kayak shaft, the first idea, in the small garden house of my grandmother. So we built our first winding machine in this small 4 square meter place. And meantime, we started to invent new process called MF1 to MF5 from 2004 to 2023. And we sold more than 200 filament winding all over the world and equipment also. So in 2023, I create my company EFC, means EF Emmanuel Flouvat Conseils, means Conseils advice. And since that, I traveled the world, and also in Europe, or also here, for example, in Australia, and technical support for filament winding technologies. And I assist also my customers to develop their own process for filament winding techno. So where I am involved today on some small parts, for example, continuing for developing kayak shaft. I assist my customer also to develop gas tanks or some other kinds of shaft or propeller system to new system with filament winding is easy to use or maybe sometimes on a complex way. So this is the job I'm doing today everywhere on the world. So robotics origin. So this is the first picture I find. Or maybe the oldest, the Leonardo's mechanical knife. Maybe it gives an idea how robots can assist, or maybe it was the first idea of Leonardo, where the mechanic can assist a human. So the first video I find, or some colleagues, we discussed first robot. It was in the US in '59, where 2 guys developed this new kinds of machine. So maybe 59, but it was the first idea of a robot, but it was very accurate. So the robotic today, what we know that robotic is everywhere in the world. So another video to introduce the robot today from the IFR, International Federation of Robotics. So automotive is 30%. That's big numbers. Electronics, 26%. Metal industry, 11. So it could be shared with automotive to weld the frame. And investment today is huge. The huge amount of investment for robotics all over the world. So in top 5, China, Japan, US, Korea, and Germany. Nearly 80% of the robots in the world. And some by region, 2.5 million in Asia, Europe, 700, America, 400, nearly 500. So this is the robotic today. So the total installation, it's a huge amount, and we can see on this picture that it's going better and better year after year. So we have more and more installation all over the world. The critical things today, we know it's that the number of companies to install robots all over the world are not enough. So the installed robots, so in 23, it was plus 10% of the number of robots installed all over the world. So to continue, we'll speak about filament winding and about the filament winding origin. So I travel a lot. So most of the time when I ask some people where the filament winding is coming, for sure US say this is coming from us. But I do not agree with them. So for me, it's coming from Egypt because this is in a Museum of London. And for me, it's maybe the first idea of filament winding. So you use a tape and you wrap something. So this is the most or the oldest techno that I can find somewhere. So there's another way to make the most simple. This is a video I find on this is a real filament winding. So the guy is walking inside and we have a cross carriage with the fiber. So we'll see, this is for me the simple machine. So the fiber, you just have to move the resin bar from the front of the tank and it's working. This is simple. Low cost, low energy, low CO2 emission. So it's something that we can think about. The first time I see, I saw, excuse me, a picture of filament winding robot. It was on this French book from a man called Maurice Rhine. And the title is How to Use Composite Material at the Best Cost. So I saw this picture. This book was in '86. I think I find these books early 2000 or something like this, and it gave me an idea that maybe we can do something with composite and robotic, and to make or to produce some complex shape. So today, where are the filament winding robots or the equipment that I know? So they are nearly everywhere in the world because at MF Tech we sold in the past like 200 machines, close to 200 equipment. So to make some high volume parts, so we can compare like for gas tanks for cars, for H2 or CNG, could be for scuba also. A lot of scuba bottles, they are made with composite. Long parts, it could be rocket motor case. Small parts, it could be also small rockets or small launchers. This is so we have a lot of weapons that are made with filament winding today. So we have several methods so to wind the parts. So the classic method with robot, you can imagine that we have a kind of spindle. This spindle is moving the part, and so the machine is coming and applying the fiber on the mandrel. What we call the mandrel, it's the rotating part. So here an example of some equipment of MF Tech. This is a company called Wintech in Norway, and they are winding some tubes and to make some Kevlar all around to make a protection. So this machine was also transferred to USQ 3 years ago, if I remember well. And this is an equipment where you have a spindle. You can imagine the part is rotating, and we have the robot to move the delivery head. And on this delivery head, we can load the bobbin, some top rags, some different kinds of material. And some recently, this is the format of the machine, what we can do, top rag, slit tape, wet winding. And this week, I installed this filament winding system, a new option on the machine. We put like a wet winding head. So here we can see that we are winding with 4 fibers. And these 4 fibers, before to be applied on the mandrel, they are going to this rotating system, stainless system on a drum, and we have some resin. So we are able now to use some dry fiber and some resin to make impregnation directly on the machine. So it means that we can use different kinds of resin, different kinds of fiber to be able to wind new prototypes, new equipment, or to test new fiber, to test new resin on the machine. So this is the equipment that you can use today here in Toowoomba at the USQ. Coming soon also a new option on this winding machine, because we are able to remove the winding head and to put another tool. So it could be like a 3D printing system or other things, milling spindle, gluing gun, and make what we want. And we are working also with a new partner, Carbon Axis, and we will remove the head of MF Tech to put this head of Carbon Axis, and we will be able to make some fiber placement. The difference between fiber placement and filament winding, we have rotation of the mandrel, and the fibers as a continuous path. And with the fiber placement system, it's a non-continuous path, and we apply the fiber where we need to apply on the mandrel to make some localized patch, for example. It could be on the drum, it could be on the flat panel. So with this system, you can see the drawing on the bottom of the picture, what we are able to do with this kind of machine. So another example, we don't have this option today on the machine at USQ, but we can imagine also that the robot is carrying a small spindle to make some different kinds of parts. So the fiber could be static. We can imagine, for example, a thermoplastic application. All the mechanic to make the impregnation is very complex. So it's very low to carry on the robot. So in some case, we can carry the part directly on the front of the eyelet to be able to wind the part. Moving mandrel, so it's another application by MF Tech. All these videos, you can find them on YouTube. This machine, the moving mandrel, it's because sometimes when we use some pitch fiber, for example, this fiber is very easily to break. So we can imagine that we have a straight path, and to avoid the deviation on the fiber on a lot of rollers, we move directly the spindle on front of the eyelet of the robot. And this equipment also, the robot can change the head on several. We can imagine to have aramid fiber, glass fiber, carbon fiber. So in an automatic way, the robot can change its own head. So I asked recently to IA what will be the future of the robot. So this was the question. What will be the future of robotic? So it takes a few seconds. I use this copilot for this. So we have a lot of answers. So the answer that is coming really fast now with IA and robotic today is that robot will work more with human. So a lot of people think that the robot could be dangerous, but more and more we are going to automation, we are going to collaborative robot, so the human can work directly. We have a lot of safe process to assist human and to be sure that the robot is not dangerous for the people. And expansion in new industry. So today the robot is well known to handle some things and to make like non or dirty things that human cannot do. But with filament winding today, you can see that we use on a more maybe glorious things, that the robot is easy to use for different kinds of application. So the growth of the robotic, as we can see a few minutes ago on the video, is more than in the last years. We have more and more growth and production of robots all over the world. So from United Nations, so the Sustainable Development Goals, so we can see that there are 17 points from the United Nations. And 7 points the robotics can reach. So you will see in details later in the presentation. So conclusion, or what we can say is conclusion, robotic is not dead for sure, because some people, they were thinking some years ago that the robot is not enough accurate, not enough safe to be developed for new application. But now we can say that in the last 5-10 years, it's totally different. We use the robot everywhere. Also for surgery, for example, or for X-ray now to treat cancer. Sometimes we use robot on some case. And for the question too, it's that we need more integrator. So what we know today, there's not enough company to build machine with robots and automation. That's a big problem. I don't know here in Australia, but in Europe, it's a bit critical. Not enough people also. Some example of what could be the future of filament winding. So at MF Tech, we also create some years ago this called MF5. So this is an idea where you can rotate the spindle and the robot, they can handle directly the parts to be wound on the front of the eyelet. It could be also this way, where you can have kinds of parallelogram robot and a human robot. They work together instead to have a man. This is an idea. And this one by Stark and Industry, I like it. It could be because Iron Man maybe is dead, but not in that way. So it's a joke, but it's maybe a way that we can use the robot too. So step of study. So if you need something to be help on your project, so first you can call me or text me or email. And here for Australia, I'm working with Tristan nearly every day. So you can also contact for some filament winding subject. Tristan has a large experience also for filament winding. And so we can discuss together and work together on several new projects. So this presentation was made with ChatGPT, also Copilot. I use a lot, and YouTube, and a bit of my experience. So thank you very much.